Here we have a problem in algebra 2, that is we have to solve for x in the given rational equation. Okay, when I look at the given rational equation, I find the same denominator x94 on both sides of the equation. So if I multiply both sides of this equation by x94, I'll be able to get rid of the denominators. Once I get rid of the denominators, the fractions will be no more and I can solve for x easily. Okay, now let me write the given rational equation as it is. It is x square positive 4x positive 2 over x negative 4 equals to 3x positive 8 over x negative 4. Okay, now what I'm going to do is I'm going to multiply both sides of this equation by x negative 4. Let me do it on the left side, x negative 4. Okay, the x negative 4 will cancel out and x negative 4 will cancel out. Now let me write the resulting equation, that is x square positive 4x positive 2 equals to 3x positive 8. Okay, now we have a quadratic equation in the variable x. Okay, to solve for this, to solve for x in this quadratic equation, what I have to do is I have to get this quadratic equation in standard form. Standard form means we have to get everything on the left side. On the right side, we must have 0. Okay, let's try to make the right side 0. For that, we have to get rid of this 3x and positive 8. So for that, I subtract 3x from both sides and also I subtract 8 from both sides. Let me finish. So this positive 3x, negative 3x will cancel. Positive 8, negative 8 will cancel. X square, when I combine this positive 4x and negative 3x, I'm getting positive 1x. When I combine positive 2 and negative 8, I'm getting negative 6 equals to 0. Okay, now we have the quadratic equation standard form. Okay, I think this quadratic equation can be solved by factoring. For that, we have to multiply the constant of negative 6 by the coefficient of x square, that is 1. When I multiply this 1 and negative 6, I'm just still I'm getting negative 6. Now I have to get two factors for this negative 6, so that the product of the two factors equals to negative 6 and the sum of the two factors equals to the coefficient of x. In this case, it's positive 1. I think positive 3 and negative 2 will work. When I multiply positive 3 and negative 2, I'm getting negative 6. When I combine positive 3 and negative 2, I'm getting positive 1, which is a coefficient of x over here. Okay, to solve the quadratic equation further, what I have to do is I have to divide both these factors by the coefficient of x square, that is 1. Okay, when I divide this positive 3 by 1, still I'm getting positive 3. When I divide this negative 2 by 1, still I'm getting negative 2. Okay, now to get the first value of x, what I have to do is I have to change the sign in the first factor. So here already we have positive. If I change the sign, I'll be getting negative 3. So the first value of x in this quadratic equation is negative 3. Now to get the second value of x, I have to change the sign of the second factor. It's already negative. If I change the sign, it will become positive 2. So now I got two solutions for the given rational equation. Always the solution we get for the rational equation have to be verified with the given rational equation, particularly with the denominators of the rational equation. So here we got two solutions. So both the solutions have to be verified with the denominators. That is, so we have to check whether any of the solution makes one of the denominators of the given rational equation as 0, because if the denominator becomes 0, then the value of the fraction is undefined. Okay, now let's check whether the first value of x, that is x equals to negative 3, makes any of the denominator in the given rational equation as 0. So now let's plug in x equals to negative 3 to the denominator over here. When I plug in x equals to negative 3, I'm getting negative 3, negative 4. Anyways, it's not equal to 0. So the same stuff we have over here, x negative 4, we don't have to verify with this one. Okay, so the first value of x, that is x equals to negative 3, does not make the denominator we have in the rational equation as 0. So we can consider the first solution as a valid solution. Okay, now let's verify the second solution, that is x equals to 2. For that, we have to plug in x equals to 2 into the denominator over here. When I plug in x equals to 2, I'm getting 2, negative 4. So it's not equal to 0. So the same denominator over here. So we don't have to verify that one. So the second solution, x equals to 2, also does not make any denominator in the given rational equation as 0. So we can consider this one also as a valid solution. So the solutions for the given rational equation are x equals to negative 3 and x equals to 2.